Evangelista, and welcome to another episode of Evangelista Science. In this episode, we're going to talk about the activity series, part of the IBChem curriculum. And so, in a redox equation, we need to identify the oxidizing and the reducing agent. And these are a little bit confusing because they're kind of backwards. The oxidizing agent is actually the species that gets reduced, and the reducing agent is the species that gets oxidized. So if you look at iron oxide plus carbon, we get iron metal plus carbon monoxide. We notice that iron is going from +3 to 0, so it's actually gaining electrons. So it's actually going under a reduction reaction, but we call it the oxidizing agent. The reducing agent, we see carbon's going from 0 to +2, so it's losing electrons. Losing electrons is an oxidation reaction. So it's called the reducing agent because it is the one doing the reducing to the iron oxide. So it's kind of backwards. Now, more reactive metals are stronger reducing agents than less reactive metals. We can see that through this activity series here, with magnesium being the strongest reducing agent and silver being the weakest reducing agent. More reactive nonmetals are stronger oxidizing agents than less reactive nonmetals. And we can see that with this activity series here. Fluorine being the strongest oxidizing agent and iodine being the weakest oxidizing agent. Now you can think of these activity series as kind of like a hotness scale, and atoms wanting to be with the hottest elements possible. So the higher up the scale, if a reaction with a hotter element is possible, then that reaction will occur. Let's take a look at some examples. So here we have zinc with copper sulfate. Now the sulfate ion is bound to copper, which is pretty low on the activity series. And so when zinc comes along, sulfate takes a look at zinc and saying, oh wow, that is one hot element. And so does a reaction occur? It sure does. We get zinc sulfate plus copper metal. Let's take a look at another one. Here we have chlorine, an aqueous solution with potassium iodide. Potassium is right now bound to iodine, which is the weakest oxidizing agent, but it does that because of stability. But when chlorine comes along, potassium sees the benefit of binding with chlorine versus iodine. Potassium will leave iodine, make a bond with chlorine. Here we have magnesium metal with hydrochloric acid. We know magnesium is the strongest reducing agent. And so does this reaction occur? Of course it does. Chlorine takes a look at that hot magnesium and wants a piece of it. What about this one? Copper plus some aluminum chloride. Now we can see that the chlorine atom is already bonded to aluminum, which is second on our activity series. And so when it takes a look at copper, it realized that it also already has a more beneficial pairing, and so there is no reaction that occurs.